All right, everyone, welcome back to the show. Today, we're going to be talking about a paper called Auditing Prompt Caching in Language Model APIs. And yeah, this is pretty interesting stuff.
Yeah, it's a really important topic. Those kind of optimizations that we make for efficiency in AI, sometimes we don't think about the security implications, and this paper kind of throws the doors wide open on that.
Yeah, that's exactly right. So this paper is all about how prompt caching can actually leak information. And we're not just talking about, user data. They were even able to extract information about a model's architecture from this. So that's pretty crazy.
Yeah, really, really big implications when you think about how many language model APIs are out there. This is a big wake-up call, I think, for the whole industry.
Okay, so for the first minute or so, let's give everyone like a quick summary of the key takeaways.
Okay, sounds good. So prompt caching is basically a technique where the AI model stores and reuses parts of previously processed prompts to save time and resources.
And this seems harmless at first, but
But it can actually increase vulnerabilities, so the researchers developed these audits to test if this was actually happening in real-world APIs.
and they actually found it too, right?
Oh yeah, they tested 17 API providers, and 8 of them had prompt caching vulnerabilities, and 7 of those had global cache sharing, which is the most concerning level.
Whoa, global. So that means like anyone could access anyone else's prompts.
Potentially, yeah, that's right. And some pretty big names were on that list too, like OpenAI and Azure.
Okay, so the takeaway here is that prompt caching, even though it seems simple, can be a big security risk. And as we develop AI, we have to think about these trade-offs between performance and security.
Absolutely. And this is really just the tip of the iceberg. There's probably many other vulnerabilities out there. We just haven't found them yet.
So true. Okay, so now let's unpack this a little bit more for our viewers who really want to get into the weeds of it. How does prompt caching actually work? Can you break that down a bit?
Sure. So like I said, it's all about efficiency. These big language models are really computationally expensive to run. So developers use prompt caching to store parts of these prompts and reuse them later.
So instead of starting from scratch every time, it's sort of like saving some common phrases and reusing those?
Exactly. And the key to this is reusing what's called the attention key value cache, which stores information about the relationships between words in a sentence. So reusing this makes the model much faster to generate its response.
Much faster to generate the first token of the response, to be precise.
Yeah, you got it. So it improves that time to first token metric, which is really important for the user experience.
Right, that makes sense. So it's all about making things faster and more responsive, but like we've been saying, that comes with a catch. Can you explain these different levels of cache sharing and how they affect security?
Of course. So the researchers identified 3 main levels. The first is per user caching, where each user gets their own cache. So this is the most secure option because the only prompts that could be leaked are your own.
So it's like having your own little private workspace.
Exactly. And then there's per organization caching, where a cache is shared within a company or a group.
So now anyone within the organization could potentially see other people's prompts.
Right. That's where things start to get a little riskier. And then the most worrying level is global caching, where there's just one cache for everyone using the API.
Oh, wow. So any prompt from anyone could potentially be accessed by anyone else.
Yeah, and the paper found that a lot of API providers are actually using this global caching approach, which is concerning.
That's kind of scary, to be honest. I mean, it really highlights the need for transparency from API providers so users can understand these risks.
I completely agree. Transparency is so important when we're talking about systems that are processing potentially sensitive information.
Okay, so we've talked about how it works and the different levels of risk, but how did the researchers actually go about finding these vulnerabilities? They did something called statistical hypothesis testing, right?
Yeah, that's right. They used statistical hypothesis testing to try and see if caching was happening and if so, what level. So they set up their test to compare how long it took for cache hits versus cache misses.
So if there's no caching, those times should be about the same, right? Because everything would be a miss.
Exactly. But if they saw a big difference in those times, then that's a sign that caching is going on.
So that makes sense. But how do they know it was a cache hit or miss? Did they just send the same prompt twice?
They had to be a bit more clever than that. They created specific prompts designed to trigger cache hits and misses. So for the misses, they used prompts with just random letters to minimize the chance of hitting something that was already cached.
Oh, so they were making sure those prompts were unique, I see.
Exactly. And then for the cache hits, they intentionally sent the same prompt multiple times from a victim user to try and get it into the cache. And then they had an attacker user send a slightly modified version of that same prompt. And if they got a faster response time, that meant it was a hit.
Oh, wow. So they had to like trick the API into caching the prompt. Interesting. And this worked.
It did. In a lot of cases, the differences in times were significant enough to show that caching was definitely happening. And they even had to adjust the number of times they sent the victim prompt, depending on the API, because some APIs would cache it quickly and some took a lot longer.
Okay, so that's pretty convincing evidence that you can use this to leak information. But what about actually getting the full prompt out? Is that possible?
That's a lot more difficult. Detecting that a prompt is cached is one thing, but actually extracting the full content is really tricky. It would require incredibly precise timing measurements, and there's all sorts of other challenges, like the attacker's own prompts could end up in the cache, which makes things messy.
Right, so it's more about the potential for leakage than a practical attack at this point.
Yeah, but even that potential is worrying, especially when you consider the types of sensitive data that these models are processing.
Yeah, that's a good point. And that brings us to probably the most fascinating finding of this paper, that you can actually learn about the model's architecture from this prompt caching.
Right now, this is where things get really interesting.
All right, are you ready to dive into that?
Let's do it. So they found that this thing called prefix caching, it can only happen in decoder-only transformers.
Okay, so I know about transformers, but what's a decoder-only transformer?
Yeah, so, transformers have two main parts, the encoder and the decoder.
Right, the encoder processes the input, and the decoder generates the output.
Exactly. And in some models, you just need the decoder part, especially for things like text generation.
Okay, I'm following you. So prefix caching can only work with these decoder-only models.
Right. And here's the crazy part. They used that to figure out that OpenAI's text embedding 3 small model, it uses a decoder-only architecture.
Well, hold on. They figured out the architecture of the model just by looking at the caching behavior. That's incredible.
Yeah, it just goes to show how much information can leak out from these timing differences. It's like a fingerprint for the model.
That is a huge finding. I mean, if you can figure out the architecture, what else could you potentially learn? It really raises questions about model transparency and reverse engineering.
Yeah, it's definitely something to think about. This whole research paper is kind of like a wake-up call that we're just scratching the surface when it comes to AI security.
For sure. Okay, so we've talked about how it works, the different risks, how the researchers found it, and even how they figured out a model's architecture. But now let's get practical. What can we do to mitigate these risks? The paper does suggest some things, right?
Yeah, they do. And the most obvious solution is to just disable prompt caching completely.
I mean, that makes sense, but doesn't that defeat the purpose of using it in the first place? I mean, wouldn't it make the models much slower?
It would, but sometimes security is more important than speed, especially when you're working with really sensitive data.
Okay, yeah, I see your point, but disabling it seems kind of drastic. Are there any other options?
They suggest using per-user caching, which we talked about before, where each user gets their own isolated cache, so the only data that could leak is their own.
Yeah, that makes sense. It limits the risk quite a bit, and especially if the user knows about the caching policy, they can make an informed decision.
Exactly, and that brings us to another important point. Transparency. API providers need to be upfront about their caching policies and what level of sharing they're using, so users can understand the risks.
Yeah, transparency is crucial in this. I think users should be able to choose what level of risk they're comfortable with. But do you think API providers will actually do this? I mean, they're all about speed and performance, right?
Yeah, it's a tough balance for sure, but I think as more people become aware of these vulnerabilities and users start demanding better privacy, the pressure on API providers will increase.
Yeah, hopefully this paper will be a turning point for the industry. Okay, so moving on, I want to talk about something else the paper mentioned. They noticed some small differences in the embeddings between cache hits and cache misses, particularly with that OpenAI model. Any ideas why that might happen?
It's pretty interesting. They think it might be because of the way the cache is implemented. It might store the cached embeddings with slightly less accuracy to save space or processing power.
So it's like saving a photo at a lower resolution to make the file size smaller.
Yeah, exactly. So even though it's a hit, the embedding isn't exactly the same as if it was computed from scratch. There's a little bit of information loss.
Wow, that's really subtle, and it makes you wonder how these tiny differences might affect things down the line. It just goes to show how even small implementation details can have unexpected consequences.
Absolutely. Speaking of those details, I was curious about one of the tests the researchers did. They found that shorter prompts with less shared content were harder to detect caching. Why do you think that is?
Well, maybe because with shorter prompts, there's less to cache, so the timing differences between a hit and a miss would be really small.
Yeah, that's probably, it's like trying to find a needle in a haystack. The smaller the needle, the harder it is to find.
Right, so attackers would need to be much more sophisticated to exploit this in those cases.
Definitely. It's not an easy attack to pull off, especially in real-world systems where there's all sorts of noise and variability.
So it's not just about whether caching is happening, but how it's implemented and how that affects the detectability of these vulnerabilities. It's really complex.
It is, and it shows that we need to keep doing research in this area to better understand these vulnerabilities, develop new detection methods, and come up with better mitigation strategies.
Absolutely. Before we wrap this up, I wanted to touch on one last thing from the paper. They found that there wasn't really a clear connection between model size and the ability to detect caching. I found that surprising. What do you think?
It's a curious finding. It suggests that maybe caching behavior isn't just determined by model size. There could be other factors at play, like the architecture, the specific caching implementation, or even the hardware.
So it's not as simple as saying Bigger models are more vulnerable.
Nope, it's much more nuanced than that, and it all comes back to the need for more transparency and a deeper understanding of how these AI systems work. We can't just assume that something is secure just because it's popular or comes from a big company.
Yeah, we need to keep asking the tough questions, doing research, and holding the people who are building these systems accountable.
Exactly, and that's a great segue into the final part of our discussion where we'll explore the broader implications of this research for the future of AI security.
Right, so we've talked about a lot, prompt crashing, all the different risks, the auditing techniques, even that crazy architecture leak, really amazing stuff. But let's zoom out a bit. What do you think this research means for the future of AI security, especially as these models get even more complex and integrated into everything?
It's a really good question, and I think this paper is just the beginning. Like it's a warning sign that there are probably lots of other vulnerabilities hiding in these optimizations that we just haven't found yet.
Yeah, that's a great point. What if this prompt caching thing is just like a symptom of a much bigger problem? Like what if our focus on making AI faster and more efficient is blinding us to the security risks?
It's definitely possible. Think about all the other things people are doing to improve AI performance, quantization, crooning knowledge distillation. All these techniques involve modifying or compressing the model in some way, and that could introduce new vulnerabilities, new ways for information to leak out.
It's like we're building these incredibly complex systems, but we might be accidentally leaving a trail of clues that someone could use to exploit them.
And the scary thing is we might not even know those clues are there until it's too late. It's like we're exploring a new frontier without a map.
That's why research like this is so important. It makes us think about the potential downsides of AI progress. Not just can we build it, but should we build it? And if so, how can we build it safely?
Exactly. How can we build it in a way that protects our privacy, our security, our values? It's a huge challenge, and it's going to take a lot of collaboration and creativity and a healthy dose of skepticism.
It's interesting you mentioned skepticism. I think sometimes as AI researchers, we get so excited about pushing the boundaries and reaching that next milestone that we might overlook the risks.
It's easy to get caught up in the hype, but we need to stay critical, question our assumptions, and think about the unintended consequences of what we're doing. And that's where having diverse perspectives is so important. People from different backgrounds and fields can help us see the things we might miss.
Absolutely. We need to move past that move fast and break things attitude that's been so common in tech when it comes to AI. The stakes are too high. We need to be more careful, more thoughtful, more accountable for what we create.
We need to shift from just focusing on performance to prioritizing security and privacy from the very beginning, build it in from the ground up.
And we need to be transparent and open about the limitations of these technologies, the potential risks, and the steps we're taking to address them.
And we need to have these conversations with policymakers, regulators, and the public to make sure AI is developed and used in a way that benefits everyone without sacrificing our rights and freedoms.
That's a great point. This research reminds us that we all have a stake in the future of AI, and we all need to be involved in shaping it responsibly. So to everyone listening, stay informed, stay engaged, and keep asking those tough questions. The future of AI depends on it.
Absolutely. The future of AI depends on all of us working together to make sure these technologies are used ethically, responsibly, and for the good of humanity.
Couldn't have said it better myself.
Yes.
Well, on that note, I think it's time to wrap up this deep dive. Thanks to everyone for joining us on this journey into the world of prompt caching and AI security.
Hope you found it interesting, thought-provoking, and maybe even a little bit inspiring.
As we've seen, even in the seemingly boring world of AI optimization, there are hidden dangers and unexpected consequences that we need to be aware of.
If you're interested in learning more, be sure to check out the research paper. We've got the link in the show notes.
And as always, stay curious, stay vigilant, and keep pushing the boundaries of responsible AI development. See you next time. CTMA.